Alrighty, 2017 exam 1. You have those in the chat if you want to use your own copy. We'll start this one off at question 2, since question 1's just very bare bones basics. First up is very simple, find derivative. Then the reason we're doing 2a is because it will be important for 2b. Find dy dx, x natural log 3x.
So product rule?
Yeah, product rule, absolutely. Technically, there's also a minor chain rule in there as well, but that's just semantics.
Is it natural log 3x plus 1?
3x plus 1. Let's take a look. That's it. Yeah, nice and quick too. Well done. I had just gotten the phone out to start writing the answer and you'd already finished it. Very good. Okay, next up, hence find, or I guess hence calculate this definite integral. And yeah, sure, we will express our answer in a particular form, but that's secondary. So these kinds of questions, do you recognize the overall procedure we follow here?
Is it like because natural log 3x is the like derivative of x natural log 3x? That means the antiderivative of this is just like what we started with.
Actually, yeah, it is, because you ended up getting exactly natural log 3x plus 1. Yeah, okay, so there's literally no other rearranging, yeah.
And then
So,
you just log in 2 and then, yeah, 1.
yeah, precisely. Yeah, it is actually just a one-to-one mapping. Usually this is slightly different and you have to play with it a bit, but no, that actually is identical. Yeah.
But say if it was slightly different, like what would you want to do?
Yeah, okay, so like let's say for instance, there's an additional plus x in there. Now, I don't know if this is actually going to work because I'm kind of just making one up, but we'll see. So, oops. Okay, so let's say instead I have the integral of natural log, and it's going to be a really basic example, actually, now that I'm looking at it. If I have like this additional plus x in there, right? Now, we found that our dy dx was natural log 3x plus 1, and so the antidiff, f of x, was therefore going to be the x natural log 3x, like we started with in the question. But we still got this additional plus x in there. Fundamentally, all we're going to be doing is splitting this integral up and just saying instead of including it in that one, you now include it separately over here, plus x. And so all we're doing then is, yes, you're subbing in the capital F2, capital F1 for this, but you're also doing it for this as well. It's a simpler example, but that's the premise of it, which is get the integral that you want through a bunch of rearranging, sub in based off of this diff-antidiff relationship, and then whatever's left over is stuff that you can calculate without needing to do anything special. I can try find an example that I haven't just made up if you want to practice that as well.
No, it's all good.
That's all good? Okay.
Is it natural log 12?
Natural log 12 is correct. Yeah, precisely. Yeah, nothing more than what you said, really. You do your f of 2 minus f of 1 based off of the definite integral, and then just a bit of log law stuff to rearrange it all. Nice. Question 3. Show that this is that. Why does that look really familiar? I feel like last exam one had a very similar question. Yeah. This is definitely different though, right? Oh, this is the one that I did. This is the one that I did end to end. That's kind of funny. I forgot that I picked one that was slightly ahead. We did do this last week because I did it. That's funny. Do you want to pull up a new one, or are you happy enough to see how you go on this?
Oh, I'll do it. I think I might have missed the lesson that you did it anyways, so
Oh, sure. Okay.
yeah. So I'll do this one.
No, you were there because you gave me some. I think you fixed that one of my errors. That's the one that I
Oh,
did.
really?
I did live fully.
Oh, maybe.
Either way, I'm sure the answer specifically. It's been a while.
I mean, for 3A, do we just expand the
Yeah,
lesson?
yeah. It's just expanding. Is that what you've done, or
Yeah, I've got an x to power 3 plus 3x squared minus
yeah,
4.
yeah? That's it. Expand, expand, and then simplify. Nothing else to it. Sketching the graph. Yep. I guess just let me know when you've sketched that and we can compare to what's in the answers.
Done.
Brilliant. Okay, so key features required. Axes, intercepts, stationary points. Yeah, stationary point was already on the x-axis anyway, so I can imagine that would be quite quick. You got that shape?
Yeah.
Easy. Okay. Question 4. We've got the proportion being a quarter, p hat, so you know it's sampling and estimation. Find the smallest integer of n such that the standard deviation is less than or equal to 1 in 100.
Sure.
Not too sure. Okay. So I guess the first thing was identifying that as soon as you see p hat stuff, proportions, keywords like that, those are all, well, specifically p hat definitely is going to tell you it's sampling and estimation. It says we want standard deviation less than or equal to 1 in 100. So without really knowing anything about the question, we just say standard deviation less than or equal to 1 in 100. The next thing is to say, okay, well, how do we find standard deviation, specifically for sampling and estimation? So we pull up our formula sheet, and it's right there for us. So it's going to be the square root of p1 minus p. That's not how you do that at all. Square root of p bracket 1 minus p on n. That is the standard deviation term. So if we go back to the question, we were actually told that p is a quarter. The proportion is p, and since the proportion of angelfish is a quarter, we now have p is a quarter. So what we now have is square root of a quarter then that's going to be 3/4, and n is the thing we're trying to solve for under this circumstance. Then from there, we want that to be less than or equal to 1 or 100. Because the math gets a bit strange, I would just work off of a regular equal sign, and then work back and figure out, okay, should my n be greater or less than this number that I've just found? And if you're kind of looking at the fraction, since n is in the denominator, if it gets bigger, then this number gets smaller. So you know that whatever n you end up with, you want to be saying n greater than or equal to that number, because if the n got greater, then the number will get smaller, therefore putting it less than the target. From here, it's just algebra to do the rearranging. So I guess, conceptually speaking, how we got to this spot, was that all fair enough?
Yeah.
Okay. Do you want to practice the arithmetic on that, or shall I move on?
I mean, I got root 3 on 6, square root 3 on 16 n is equal to 1 on 100. And then I'm guessing we just got to remove the square root,
Yeah. So you
squaring both
square
sides.
both sides, yeah.
So we get 3 on 16 n is equal to 1 on 10,000.
Yeah.
And then we get 30,000 is equal to 16n.
I think that's good. Yeah.
And n is equal to 30,000 on 16. So
Yeah. Which, big numbers. Prime decomposition. So try to break them down into prime factors, see which ones cancel out, because you do get an integer off of this.
I think it's about 1875 because 16 times 2,000 would be 32,000. So
Uh-huh.
yeah.
Well, you sniped it perfectly. Yeah. 1875. Nice. And yeah, since we want n to be greater than or equal to that number, to make this less than or equal to 1 in 100, the smallest integer value is therefore the breakpoint there that we're looking for. Yeah, well done. Question 5, probabilities. What is the probability of not logging onto the computer successfully based on the following information?
$27 on 125.
27 on 125. Yeah, precisely. Just the 3/5 being a fail, and then cube it because you want to have 3 fails back to back. Maximum of 3 attempts. Yep, that's good. Part B is going to be quite similar. In fact, I think, now that I look back on it, I think I solved this in a more complicated way than it needs to have been solved. If I remember last time, I'm pretty sure I used a tree diagram thing for this, which is not necessary. Doable, but not necessary.
98 on 125?
Yeah, exactly. Did you do a 1 minus probability there?
Yeah.
Yeah,
Complement probability.
yeah, exactly. If that's not successful, then successful is going to be the opposite. Well done. Maybe I did misremember. Maybe it was C that I used the tree diagram for. Yeah.
Is C like basic conditional probability?
Yeah, in a
Because it's
sense.
like, given that he fails on the first attempt.
Um, yeah, there's a sense of conditional probability in here. You're right. Yeah. Um, I don't know how helpful it's going to be to think about it as conditional probability. Yes, you are restricting outcomes. Like, for instance, we know there's a fail on the first, so we can ignore the entire first trial altogether. Um, oh, well, can we actually? No, we can't actually ignore it because it doesn't say given a fail, then calculate probability of success on the second or third. Because if it said that, then you would fully restrict the sample size, ignoring that first outcome. Whereas in this case, it just says find probability of a success on the second or third, which means when you're doing your cascading, like multiplying along the branches, that first stage actually does matter. You've got this
Right?
initial probability to worry about.
So is it 48 on 125?
Yeah, exactly right. Nice. Now, was there might have been a different way to do this? Was that just saying fail then success, fail, fail then success?
Yeah, I mean, I already made my tree diagram with all the probabilities at the end, so then I just
Oh,
added up.
sure.
I added up 6 on 25 to 18 on 125, and that's what I got.
Hmm. Yeah, okay. And I guess, yeah, if it was conditional, then you would have dropped one of these 3/5 on both of them, because then you would just sort of ignore that because it's the given, that's the new total, it's the new n. But yeah, that's good. Question 6. State all possible values of tan theta.
Is it pi on 4 and pi pi on 4?
So that would be solving for theta. This is solving for tan theta. A little bit
So
different.
1?
One is one of them. Yep.
Oh, and then
Now,
the linear division of cos base.
yeah,
Alright, cool. Let me try that real quick.
yeah. It's a cheeky little one.
Okay, so it's gonna be 1 and then plus or minus root 3.
Yeah, those are correct. Absolutely. Hence, find all the solutions. So this is where now we're definitely solving for theta. So that previous solution you had for theta is definitely going to matter. Um, Now, oddly enough, they did sort of change up the function. I'm assuming that's probably just the expanded version. Assuming. Looks
Yeah.
like it.
No, I think I can tackle this one real quick.
Yeah, yeah.
Is it pi on 3 and pi on 4?
Pi on 3, pi on 4 are good values. There's not all of them though.
It's another one.
There is another one. Yeah.
Mm,
So you're going from 0 to pi. Um, I think you would have solved where tan was 1 and where tan was root 3.
yeah,
Yeah. Is that everything you found in the previous question though?
we had
Yeah. There's a
minus
minus
root
root 3 as
3.
well.
Oh, plus minus. Oh, I
Yeah,
see.
plus minus. Okay.
Right, so then is it just gonna be, wait, hold on.
Yep.
But, isn't tan theta equal to negative root 3? Isn't that gonna be, a negative solution?
Uh,
No, I won't.
mm, no, not necessarily. I mean, there's always a
Like,
positive and a negative
won't it be outside the domain?
because it's in quadrant 4.
Yeah,
Where else is it?
quadrant 3.
2. So tan solutions are always separated by pi, so diagonally opposite from each other. And so there's always going to be 2 solutions for practically anything on the unit circle. There's some exceptions, of course, if you're on the quadrant boundaries. But yeah, you found the quadrant 4 one. The other one is up in quadrant 2. Tan has always got separated by pi. So it would be the 2 pi on 3 solution there, basically.
Okay.
Makes sense why that's there? 7a, range of f. That'll be very quick.
0 to infinity.
Well,
Uh,
maybe not that quick.
range. Oh. Mm, wait, but that's the X translation inside, right?
Yeah, that's a translation. You're right.
So wouldn't the
Oh, hang on.
range still be 0 to infinity?
Oh, hang on a minute. Why did the answers have 1 to infinity in there?
What the?
What? Hang on a minute. That's crazy.
No.
Why does the exam report have 1 to infinity?
Do you think it's just a typo or like is that genuinely like
That's
what they marked it
official.
on?
I mean, there might have been a redaction on it, but wow.
Yeah, I was about to say like
1 to infinity.
surely
I mean, that would be then. What were they thinking then? Because this is a. I guess they thought the plus 1 was at the front.
you can't even justify that for domain because if it was
Yeah,
domain,
exactly.
it'd be -1.
It'd be exactly, you're right. So that's why I'm thinking they might have thought the plus 1 was on the outside of the root. That's probably the only way that works. Wow, okay. Yeah, no, you're right. The assessors publish this and I'm
35.
65, but that's the weird bit. So 65% of people still got that quote right.
No, surely they marked them on 0 to infinity. I don't.
Uh, I would hope so. Yeah,
If they
that's
did, then 35% is crazy. Like 35% of people
yeah,
are marking them.
that is quite crazy.
It's just brackets maybe.
Uh, yeah,
Because
that was
it's
the main thing
like
there.
it's not even saying that like a lot of people like wrote 0 to infinity. It's just saying
Yeah, yeah, yeah.
way around brackets.
Weird. Okay. Anyway, we'll ignore that one and we'll hope they fixed it in time for people to get their proper marks. Okay.
Wait, just
G.
to clarify, right?
Yeah.
A subset mean like so the values of the range will be like inside the values of the domain of F.
Yeah. Yeah, precisely. Subset. So the picture is always you've got set A, which is this big circle, and you've got set B, which is entirely enclosed within set A. So set B would be considered a subset of set A. Might have to start calculating these on the side just in case the exam report gets it wrong again.
Is it going to be -2?
The answers don't have that, but how did you get -2?
I think you have to cut it off at its. Oh no, never mind. We got to cut it off at its first x at the negative x-intercept.
Yeah, so okay, you chose
My
the
bad.
turning point of it to maximize.
Yeah,
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 okay.
my bad, my bad.
Yeah, that's the inverse stuff.
Is it x is equal to -3?
Yeah, yeah, -3 is what you're looking for there. Um, just as a minor nitpick there, you'd want to write down C, -3, but otherwise, yeah.
Okay.
Precisely, yeah, exactly as you said. Solve the x-intercepts, and because pointing from left, then you want to choose the -1. Obviously, if it was now c to infinity, you would have chosen the other one, which would have been -1 instead. Very good. Double I. For that value of c, what is the range of f of g now going to be?
I was thinking about the function first, like what the function would be.
Hmm.
And is it going to be x plus 2? If
As a net
the
function.
f of g of x, like, would that be the function?
Well, you'd replace the x specifically with x squared plus 4x plus 3, because you're shoving g into f.
Yeah, and that becomes x squared plus 4x plus 4, which is also x plus 2 squared.
X plus 2 all squared. Oh, okay. Yeah, sure.
But then
Understood.
I'm guessing like, with restricting it to -3, it has probably something to do with the range.
Uh, well, hang on. So, I mean, yeah. So the rule's going to be fine. What you've calculated. The domain is going to matter because you just got to know which of these domains is the domain for the composite function, and then based off of that, you can now say range off of the rule that you've just found.
Is the range going to be 2 to infinity?
2 to infinity is correct. Yeah. So I'm assuming that means you took the g as a domain.
Oh, I took f as a domain
That's interesting. Still works out if you choose f as domain.
because the rule of f of g of x would be x plus 2. And then if you took it from 0 to infinity, that would just be 2 to infinity instead for range.
Does it work out either way? That's interesting.
I don't know if this is like just like a one of those like ones where it works. So you're meant to take
Yeah.
the infinite one as a domain, or
Yeah,
is it?
because the way the composite function works is you have some x value, it gets fed into g, and then whatever comes out of g then gets fed into f, and then finally you get your y value at the very end. So the domain of g should be the one that's yeah, the bottleneck there. But I've also noticed again, kind of strangely, they've started writing h. Like, I feel like something
In
about this
grammar.
print is super strange. So they've also got this. Something
It's
about
not
this seems
called
off.
folder. That's not even the function.
Yeah, it's not the function. Range is right, but and they talk about h as well, like and domain of h being real. There's nowhere. This is a strange thing. I might have to just re-download examiner's report on this one. So have a work on C, and hopefully by that time I'm able to grab another copy of a hopefully redacted slash fixed examiner's report. No, my phone just died. Oh, not died, crashed.
I mean, for C, the function is x squared plus 4.
See, the
Maybe
function
that's
is.
where the examiner's report is like,
Oh, sure. Oh,
maybe we weren't reading the right part.
hang on. Yeah, no, I just noticed that actually. So look, if you have a look at 7A and 7BII, they had 1 to infinity for
There's one
BII.
to because I said 2 to infinity, so
Yeah, okay, well maybe we'll just double check that then. So if I go square root x squared, oops, square root x squared plus 4x plus 4, that's going to give you x plus 2. Oh, and that's probably why, yeah, okay, that's probably why now that you took the domain of f rather than domain of g, that's why it might have come off. Because you want to go from negative infinity up until -3, and you're doing absolute value of the, yeah, okay. So it's because we didn't actually, well, when you gave the answer, you used the domain of f rather than the domain of g. That's why that's off.
right.
Yeah, the exam one report was amended on 17th of October 2018. This was a 2017 exam. Oh no.
Because I'm not sure how to do the range. Is that before like you go to explain it? Do we use some for range? Do we use the outside function?
Yeah, so there's a couple ways you could do it. One is doing exactly what you just did for double I, which is you shove h into f, look at the function, and then use the domain of h as the domain for that new function. So um, the whole root x squared plus 4, and then just saying, okay, for all real numbers, what does this look like now? The other thing you can do, because sometimes that function comes out really, really nasty, that one wasn't too bad. You could just draw the quadratic and then just root the bits that matter. The alternative, if it does come out quite nasty, is to think of the sequence that I just drew out, which was you, in this case, you've got first into h. So you figure out, okay, all real numbers into h gives you a range of 3 to infinity. That now becomes domain of f. What does the range of f look like if it has a domain of 3 to infinity? That can help you if it's a nastier function. In this case, it wasn't too bad. Fair enough.
Yeah.
Cool.
Is the range going to be 2 to infinity then?
Yeah. Yeah, it's going to be 2 to infinity.
I mean, I guess because the quadratic is going to have a turning point at 0, 4, and then you just square root the
Mm.
values.
Yeah, precisely. For range, you want to know what's the bottom, what's the top. It's a quadratic, it's going to have an infinite top, so you just care about the absolute bottom. Hey, nicely done. Question 8. We might get through the whole thing. 8, 9. Oh, we might stumble over here because I definitely did, and I did it live. Question 8 shouldn't be too bad though.
The probability of A is 4p.
Yeah, 4p, absolutely. I'm curious because the exam report has a fairly direct way of going about it. Did you go direct like this, or did you expand out the conditional probability formula and rearrange?
Um, I just did p over probability of A is equal to 1 on 4.
Yeah, yeah, okay. So that'll be the expansion of the because you got the intersection divided by, um, yeah, divided by a. Yeah.
Yeah.
Part B, find the intersection of the complements.
I got 1 minus 10p.
1 minus 10p is a little bit big. Did you use a Venn diagram? Oh, sorry. Did you use a what's it called? Carnot table, the probability table
No,
stuff.
not a K map. Just thought of it as like a Venn diagram approach.
Venn diagram. Okay. Cool. Cool.
But I can use a Venn di I'll use a K map real quick.
Yeah.
Just
See if
just
it came out does a bit better for you. Both are equivalent, by the way. They're the same thing. It's just a different way of visualizing it. I'm curious if you get a different answer though.
No, I don't think I got it right. My map.
Okay, let's take a look. So that's what it's supposed to end up looking like. The A intersection B, that one's a given. It's just P. We were told that at the start. Um, 1 is quite obvious. That's whatever. You calculated A is 4P before, so that's going to give you a free 3P over here because of those two that we know. It's going to give you
Oh wait,
this.
no, I got it right. My
Oh,
bad.
oh okay.
Sorry. But anyway,
Easy. Yes, that's the KMAP way of doing it. There's also the if you yeah if you use like the union equation and then complement it, because the A intersection B intersection like dashed is the complement of A union B. That's another way you could potentially have done it, but that's a bit more a few more steps. Part C. In fact, that might have helped for solving part C because you'd actually have an equation for A union B off rip, but it's not that hard to get it now that you've got a table.
is P less than or equal to 1 on 40?
Yes, but that's not all of it. I'm trying to think of a way to word that that doesn't give away the other thing that wasn't considered. You'll get 1 mark for that. If I give any hints, I think I'll just give it directly away. Like you got the target number. That's good. Something else that needs to be present in that answer. And it's not like a minor nitpick. It's yeah. Any luck?
Oh, sorry, I just like
Yeah, I know you are disconnected.
was out of the call real quick.
Yeah, how because I see from what I saw you left and then came back within like 30 seconds. How long were you actually out?
Good, probably a minute or so. Like first, like
Yeah.
sometimes it freezes, right? Like after the weather on the weekend,
Hmm.
connectivity and stuff hasn't been great.
Yeah.
So
Yeah.
usually I wait because sometimes it comes back, but then if it doesn't, then I have to leave and then rejoin.
Oh, sure. Yeah, I get it. Yeah. Because on my screen it only shows like when your account has disconnected and then when it's reconnected.
Yeah,
But fair. So did you come up with anything, I guess, while you were frozen?
nah.
Nothing? Okay. Um, P is a probability. That's the hint that probably gives it away. What is it about the answer you gave that's incompatible with probabilities?
And it has to be more than zero.
Yeah, that's it. Has to have an upper bound, a lower bound rather, of 0. So not just saying less than or equal to 1 on 40, but also capping that off.
It'll be more than like more than or equal to, or just more than zero.
Well, I'll let you rationalize which way. What do you think's more appropriate?
Probably has to be just more than, because if, well, actually, hold on. Union A, union B. Yeah, it has to be more than
Why does it have to
zero.
be more than? You're right, but why?
Because the probability of A and the probability of B
Mhm.
are like more than zero.
Well, probability of A is 4p and probability of B is 5p. So if you had p 0, that's fine, because that just means they're both 0 probability. Where does it say they have to be greater? There is a spot in there that tells you have to be greater, but asking you to find what specifically forces them to be positive, non-zero.
I'm honestly not sure. I think it's something to do with the addition rule, maybe,
Well,
or
it's
conditionals.
these, right? So if these are like actual non-zero probabilities, and probability of A, probability of B, those are both used in those. Um, well, if you had those as 0, then well, you get undefined realistically. But yeah, so it's more so the fact that conditional probabilities exist that P has to be a non-zero number.
Yeah.
None of that's required, by the way. Obviously, if you just well, I guess it is slightly required to understand for greater than 0. It's probably intuitive to say greater than 0 just because, but it's good to know like specifically why. Yeah, we should be able to get through enough of question 9 right before the really hard bits. Area between f and the x-axis. That's pretty chill. Function's a little wonky for it, but doable.
Is it 4 on 15 yet squared?
Yeah, yeah, it's going to be 4 on 15. That's good.
Gradient of the tangent to the graph of f is. So this is gradient and derivative and sub in x.
Yeah, derivative sub in x, which of course just is just a derivative at that point.
Yeah, I got that.
You got it? Yeah.
Yeah. When you
Nice.
do the derivative, you get like 1 onto root x minus 3 root x onto, and then you rationalize to get that
Yeah.
last fraction.
Yeah. Yeah, it's more like combining the fractions there. Yeah, because you're multiplying both
Actually,
denominators
no, this is
across.
like reverse rationalizing, actually.
Yeah, it's kind of the opposite. It's well, I don't even think it could be technically considered rationalizing because all you're really doing is combining denominators.
Yeah.
Multiply right hand side and left hand side by the equivalent or the opposite denominators.
Oh, I
Um,
think I remember this question.
yeah,
I definitely
there we
don't
go.
remember the answer, but I do know like
There we go.
it's a hard one.
Yeah. I think was it the first one that was fine? No, okay, yeah. So I knew what went wrong. Um, we'll probably just leave that there. What went wrong, and we'll talk about what's actually going to be right. Let's see how many of the broad steps, because a lot of the concepts we were talking about were perfectly solid. I just happen to suck at arithmetic at that
Okay,
given
I'm
moment.
gonna walk through in this question just so I don't make like any mistakes that maybe you did.
Yep,
Um, so it says for theta is equal to 45 degrees. Okay,
yep.
so that means the angle that the point B makes with the horizontal axis is also going to be 45 degrees.
No, theta's over here.
Yeah, but triangle has to be 180 degrees, right?
Well, the angle that B makes with the horizontal axis will be considered over the right hand side, not the inside of it. But okay, I get your point then. So there's a 45 in here, yeah, not a 45 out there.
Yeah, my bad.
All good, all good.
Okay, so I think that using that we can find the gradient,
Yes, we can.
and so tan pi on 4
Yep,
is equal to 2, wait, is equal to 1,
is equal to 1. Yep.
except that this is a negative gradient.
Hmm.
So does it just become negative 1 or like,
Yeah, so the accurate way of doing it would be to say this is tan of negative 45 degrees because the 45, when you're doing the thing you're shoving into tan theta, it needs to be as if it was a unit circle. So you'd either shove in
yeah,
the
okay.
135 or the negative
It's in the
45.
second quadrant.
Yeah, yeah.
Cool. Okay, negative
Um,
1.
negative
And
1, yep.
then plus C is going to be where it intercepts. And
Yep.
for that, we need to find a point. And I think we can do that through like the tangent.
Hmm.
Yeah. Okay.
Yeah, so
Let me
we're
just
on
write it
this,
down.
yeah, we're on this graph where you have a gradient negative 1.
So we need to equate the derivative to negative 1.
Yep. Still getting the same result. What? Actually, now I have the luxury to check the answer. There's no way that was legit. Okay, you're gonna get an answer that doesn't look legit. It's legit.
Okay, very confidence inspiring.
Yeah. We're about to hit time. Are you close enough to getting one?
I found the x coordinate of the point that is going
Hmm.
to intersect that.
What'd you get?
1.
Yeah. So they drew this. The graph is defined from 0 to 1, and yet, they drew it over here. X equals 1 to me did not look legit. Like this is me having a panic the first time I did it, and I was like, why the hell have I got x equals 1 and 1 over 9? Like 1 over 9, definitely not. X equals 1, surely not. So I guess the lesson there was we were short on time at the moment, so I just sort of shoved that back in because it was the best I had, and apparently that's just it. That's ridiculous. How does that get there in a real exam? Crazy.
Yes, then C is also equal to 1. Wait,
E,
actually, now that I think about it, now that I think about it, if the gradient was negative x, it was pretty like straightforward that C was going to be 1.
um, wait, what?
Because if the gradient is 1, right, that means for every x value, it also goes down like 1 y value.
Yeah,
Like, so that means at negative, like, okay, wait, hold up. So you know when we have a gradient of just positive x,
yeah. It goes
that
straight to the
every
origin and goes up.
yeah, like every single like x and y coordinate is usually the same.
Yeah,
It's the same way for negative x. It'll just like
it'll just be the flip.
it'll just be like a flip, yeah.
Yeah, but why does that now mean c equals 1 does what you want?
Because that's where it would have that's where the y-intercept would have been. And I was like trying to solve by subbing in points.
But if you just have negative x, the y-intercept would be 0. Like, how do you know the y-intercept would have been at 1?
Oh yeah, you're right.
Yeah, I
My
think
bad.
I think what you did was required. Yeah, I was
Yeah,
just
well,
curious if
it
maybe you
is.
had
My
a.
equation is y is equal to negative x plus 1.
Yeah, that's what it ends up should be. Yeah, yeah. Anyway, crazy though, right? Like, I would have. I mean, I obviously did end up writing it anyway, just because it was the best you got. But that's crazy to show up like that on a real exam, and it's not even. Okay, now I'm getting really complaining, but like x equals 1. Um, no, I guess maximal domain still works out because I was gonna make a complaint about like differentiation at endpoints doesn't work, but I guess because maximal domain this would continue if it could. Anyway, whatever. Um, that was the weird bit there. The mistake
Uh,
I made in mine was choosing gradient negative a half just because God knows why. I just thought it would. But yeah, cool. That's about it for that one then. We almost went through the entire exam, just the two of us pretty much. Like, yes, we skipped question one, but question ones or whatever, we could have blitzed those out fairly quick. Um, you're in a good place, all things considered. Like, I didn't have to critique too much and fix much at all, which is really solid to see. Like, you're doing genuine exams that have happened. It's nice to see.
okay. I was going to ask, because like for
Yeah.
now, I know there's another person who sometimes joins the class, but
Mhm.
it's usually just me.
Yeah.
On Monday class, can we do like more like probabilities type of stuff?
More probability stuff. Yeah. Yeah, we could do a
Yeah. This is the main thing that I'm like lacking, I guess.
yeah. Yeah, I'll make a. In fact, I'll put it in the calendar right now to do probability stuff. I did forget to check the Google form.
You know
Did
how
you?
like I guess I think this year and during like start of term 3 or end of term 2, You guys are doing like the actual like content type of probability.
Say again, sorry.
You guys will, I think like at the end of term two
Hmm.
and the start of term three, we were actually doing probability, like the proper content.
Yeah.
Could we start doing that again or
I'll go straight back to. Yeah, yeah. We could restart that up.
I mean unless like there's actual curriculum.
No, I mean I'm doing this just because it's a general thing and everyone's done all the content at this point. But obviously it's just yourself and Shiloh, and
Yeah.
Shiloh only joins on the Mondays anyway. So on the other, at the very least on the other days, we could do that absolutely. But I
Yeah,
feel
I
like
don't mind doing an exam like at least once a week because
yeah,
at honest, like the exams gave me like a lot of learning. Like,
yeah, okay. So we could do exam stuff Mondays and then the Tuesday Friday we can do is just the probability curriculum stuff. Do you want to do it end
yeah,
to end, or do you want to? I guess maybe just shoot me a message if there's anything specific, because you'll be the only one here for the Tuesday and Friday.
yeah.
So if you want specific probability stuff, I'll just do a
No,
custom lesson for it.
probably just end to end. Honestly, like
Yeah, sure.
considering where I'm at with probability, I'm like pretty.
Yeah,
I can be pretty clueless sometimes when I see probability questions.
no worries. Cool. I'll put that on mine every right now.
Yeah, thanks.
Easy. See you next time.
Okay.